Hi everybody, today we're going to do Chapter 12, Lesson 2, Slope of a Line. Please fill in your table of contents. In this lesson you will be able to find the slope of a line and you will be able to use slope to understand and draw graphs. So if we talk about slopes, well especially here in Minnesota, usually you think of like skiing or a hillside. And slope in math, it does define the slant of a line, how much a line slants. It could slant this way or this way. But with a linear equation, it's important to note that linear equations have a constant slope. And what we mean by that is it's not going like this and then going like that and like that. It stays steady the whole time. Here we have a note sheet so that you can keep all of your notes about different kinds of slopes in one. Well, first let's just talk about what is slope. So let's fill this middle section out first. First thing, sometimes in math the letter M is used for slope. Actually, I shouldn't say sometimes, quite often. And I don't know why they use M, but I always tell the kids M is like for mountains, and mountains have slopes on them, so M is used for slope. Another way to describe slope is we say it's the rise over the run. I'll explain more about that later, but it's the rise over the run. And because we say rise, another way to look at slope is the change in y over the change in x, like a fraction. So we always put the change in the y on top of the change in the x. Now what I want you to do is I'm just going to give you a quick reference for what different slopes look like. A positive slope, a line with a positive slope, is going to start on the lower left and it's going to go to the upper right like that. So I'll draw a few examples here. These are all positive slope lines. They start on the lower left and they go to the upper right. Okay, that's positive slope. Negative slope would be the opposite of that. They start at the upper left and they go down to the lower right. That's a negative slope. Look in quadrant 1 here. Think of you have something and it's starting to go down, 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 like maybe the price of a stock or something. Okay, negative slopes go like this. And they can be steep. They can be steep and still be negative. Okay, a zero slope. A zero slope line is a horizontal line. Now I didn't draw that very well. Let me try that again. It's a little better. It is a horizontal line and it should be totally flat. And the way you can remember that is pretend zero's a ball. If you put the ball on the floor, okay, the ball is on the floor, that's a zero slope. Okay, undefined. An undefined slope is a vertical line. Now I didn't draw that one very well. I'll try again here. So straight up and down with no slant. I'm having a hard time with this pen. But an undefined slope is a vertical line. Okay, so undefined, and zero slope would be horizontal. Well, it's practice time, so let's see these lines numbered here 1 to 4. See if you can identify them as positive, negative, zero, or undefined. So number 1, line 1, it's going this way. It starts in the upper left and goes down to lower right. That is a negative slope. Feel free to pause this and try and do it yourself and then check. Number 2 is a vertical line, and so it's undefined. 3 starts low and gets higher the farther you go to the right, and so that's positive. And 4 is a flat line, horizontal, it's zero slope. Okay, I'm going to show you how to find the slope of a line from a graph. And remember that one way to describe slope is the rise over the run. Well, the first step you need to do, and we're going to use this as our example right here, is to find the vertical change, or the rise. How much is it going up? So I'm going to look at my graph, and if I put my finger right there and I start counting as I go up, so 1, 2, 3, 4, 5, 6. So I went up 6, and if you go up, that's a positive move. So I'm going to write that 6 here. So the top of the fraction is always your y, how the y changed. Next, I'm going to find the horizontal change, or we call it the run. So I start here, and I see how many spots do I have to move over. 1, 2. So I move 2 spots to the right. And to the right is a positive move. So that's positive 2. Well, now this is my slope, 6 over 2. But I can reduce that to 3, or 3 over 1. So that's my slope. Okay, now we're going to practice. If you look at our example, what you do is you identify 2 points. So here's point A and here's point B. Now you have a decision to make. You need to decide, do you want to start at A and go down and over to B, or do you want to start at B and go up and backwards? I'm going to start at A, and I'm going to go down and count. So 1, 2, 3, 4, 5, 6. And because I went down, that's a negative 6. Okay, so going down is negative. So I'm going to put my negative 6 here. Now I need to find how far I go left and right. So I start right here where I left off, and I go 1, 2, 3, 4. So I moved 4 to the right. Moving to the right is positive. So here's my slope, negative 6 over 4, but I can reduce that to negative 3 over 2. Something cool I want to show you. Negative 3 over 2. Watch this. If I were to go down 3, watch this. 1, 2, 3 over 2, 1, 2. Hey, look it. It's right there. So it's the same slope. Okay, they're the same slope. Let's try this one. I'm going to start at this point and work my way to that point. So at first I'm going to go up. 1, 2, 3. So I went up 3. And that's a positive move. Going up is positive. So that's a positive 3. Now I'm going to do my run. That was my rise. Now my run. So 1, 2, 3, 4 spots to the right. So notice that this is a positive 3/4, and look it, it's a positive slope. You can look at your chart and check it. That's positive. And then over here, look at that. That's a negative slope. So that's a good way to double check yourself. Just remember the chart, okay, so you don't forget your signs. Now I'm going to show you how to find the slope if they only give you 2 coordinates without graphing. Now saying that, what I'm going to do first though is I'm going to graph these to show you the slope. Then I'm going to use these numbers to prove to you that you can solve it without graphing. So let's graph this point. Do it with me. X is 1, y is 2. So graph that. Now graph x is 5, y is 10. I put a little line through it there. Now I want you to practice what we did on the other page. Try and find the slope of this doing the method we just did. So count up and over and let's see what you get. Did you get 8 up? And did you get 4 over? And both positive. This is a positive line, positive slope. Then 8 divided by 4 is 2. So the slope of this line is 2. I'm going to show you now how I can figure that out using these numbers. First, I'm going to use this formula. So it says y2 minus y1. Those are not exponents. They're actually written down low. They're called subscribes. And so I have a y here and I have a y here. Guess what? It does not matter which one you call y1 or y2. It doesn't. But let's call this y1 and this y2. If you do that, then this has to be x1 and this has to be x2. You do have to be consistent once you decide. So y2, my y2 or my second y is 10. So I'm going to go 10 and put that in the formula. 10 minus my first y, 2. So 10 minus 2 equals what? 8. And then, hey, look at this. Hey, right there. Cool. Now in my formula it says x2 minus x1. So I'm going to take my x2, which is 5, and minus the 1. Okay, so 5 minus 1 is 4. Now, wait a second. Hey, look. Look at that. Same thing. Same thing. And if I divide them, I will get a slope of 2. I'll say m equals 2. M is the slope. Now let's try down here with no visual. We're just going to do it with the numbers. So first let's identify, we have x and y, x and y. Now, again, I said it does not matter which one you call 1 and which one you call 2. So I'm just going to say this is 1 and this is 2, and then this will be 2 and 1. Okay, so now I take my y's, y to the sky, and put them on top. So the formula is y2, okay, so 2, right? That's my y2, and I'm going to minus y1. Well, be careful, I'm going to do minus negative 8. This is a negative 8, so I put that there. Now I'm going to do x2, which is 1, and I'm going to minus x1, which is negative 2. This is a negative 2 here. So I would do some keep, change, change. And if I do this, I get 2 plus 8 is 10, and 1 plus 2 is 3. The slope of this line is 10/3. That's my slope. Let's try the next example. Again, x, y, x, y. Again, if you want, you can call this. Let's try calling this x, y2, and x2, and this x1, because it doesn't matter what order you subtract in as long as you do it the same for x and y. So I'm going to do 4, this 4, and I'm going to minus this negative 4. Then I'm going to do, because I use this 4, I have to use this negative 3, okay? And then I'm going to minus this x, minus this 3. So I'll do a little keep, change, change here, but look what I did. I put my y's on top and my x's on bottom. Keep, change, change, I get 4 plus 4, which is 8. And then I get negative 3 plus negative 3, which is negative 6. So this is going to be a negative slope line. Now I'm not done. I need to reduce that. And I get 4 over negative 3, or negative 4/3. Leave slopes improper. Do not make mixed numbers. Keep slopes improper. They're better that way. Easier to work with. One more example. So again, x, y, x, y. We can go back and do this as 1 and this is 2. It doesn't matter. It doesn't matter. So I'm going to do my 4 minus 0. So y minus y. Now I'm going to use this x, okay, 0 minus my other x, negative 2. Little keep, change, change. And on top, 4 minus 0 is 4. And 0 minus negative 2 is really plus 2, so 4 over 2. Now that reduces to 2 over 1. That's my slope. So hopefully that helped. Rewatch if you need to, and do your practice problems. We'll talk in class.